Hello everybody and welcome to the 8th episode in the AorbTech Pandas series. Today we're going to be taking a look at the interpolate function. We're going to be taking a look at interpolation methods, including linear, nearest, polynomial, and working with time. We're going to be taking a look at limits, including limit direction and limit area, and then we're going to be using in place. So what does the interpolate function do? It fills in missing numerical values in your data frames by estimating them based on existing data. What does this mean for us? Well, it means that for our data sets, we'll be using numerical values within our columns. Just some footnotes. You will need to pip install scipy for some of these functions to work correctly. And these are mainly the methods that we're going to be using. Nothing too difficult. You can do it in the console, you can do it in your environment by using pip install scipy. So we're going to import pandas, and then we're going to import our data sets. And one footnote to mention is that for the second data set, the machine data set, we're going to add an additional argument here called passDate with the time column. And what we're doing here basically is in this data set, we have a column in a specific format that has all of the date time values. And what we want to do is we want to convert those to date time values so that we can use them in our testing. We also have to use this over here, and this, what it does is it sets the time column that we've just formatted as the index of the data set. So that will also help us use it in our testing. So just make sure you do that, and if you're having any issues with the time method, this is probably why. So let's take a look at methods. What we're going to be focusing on in this episode is filling in missing data using other data that we have. Now, there are a bunch of different ways that we can do this, and here are the methods that we're going to be looking at in this episode: linear, nearest, polynomial, and time. And what these do are they all have different ways of filling in that data. And we're going to be exploring that shortly. But first, let's take a look at what our data sets look like. So let's take out revision. That's our first data set. And then machine. And that's our second data set. And that's what they look like. Let's take a look at the linear method. Now, this is actually the default method when using the interpolation function. And what it basically does, let's take a look at our data sets here to explain this. It looks at the missing values in our data and it ignores the index. So this doesn't have anything to do with how it's going to fill in the data. It takes a look at the missing data, which is surrounded by data that is not missing. So for example, this section here. And it fills in the data according to, let's say we start at 72 and we end at 77, right? So we find the two values that fit in between, and then we'll use those values to fill in these missing values here. That's essentially what it does. So let's try it out. Let's create a code block here. First of all, let's take revision. We're going to use the interpolate function. And we don't have to put in method equals linear, and we'll see what that looks like real quick. There you go. So these missing values here have been filled in. So the two values between 72 and 77, for example, as have the others. But what we can also do, let's say we take our machine data set. We can also set the method to linear, and it will work just the same. So you don't have to put in method equals linear, it is the default. But if you want to be specific, then that's what you can do. And just to compare these, let's create another code block here. What we should see is that the values here that are filled in are the same. So go up here. So 73.6, that's what we get, and 75.3 recurring, also what we get. So these two are identical ways of interpolation. Let's now cover the nearest method. Really quickly, let's take a look at our data set once more. We'll start with revision. And what this essentially does is it takes a look at the values that are missing and the values nearest to them, and using the values nearest to them, it will fill in those missing values. So to see what that looks like, let's take revision once more. Interpolate, set the method to nearest, and see what that looks like. So over here, indexes 2 and 3, we had these missing values. Above this missing value is 72, and below this value is 77. Those are the nearest values to each of these. And if we look down here, we can actually see that the missing value here has been filled in with 72, and the value below it has been filled in with 77. And if we take a look at another pair of values, for example, these two here, in the 4th and 5th column, or row, we can see that they have also been filled in with the nearest non-missing value. Let's take a look at polynomial next. So the polynomial method essentially analyzes our data, and it tries to fit a polynomial, so a curved line essentially, to fit our data best it can, so then it can estimate the missing values based on that. So this can be of order 2 or 3 or above, but one caveat that you have to consider is that for it to be able to do this, it needs quite a bit of data to analyze to be able to make a good estimation. So let's try and see what it does to our machine data set. So there we go. Let's try and focus on this area here, since we have quite a few consecutive missing values here. So we'll use machine.interpolate. We'll use the method of polynomial, and we'll set the order to 2. This can be any integer that you like. And let's see what it does. So as you can see here, it fits the data according to what it's analyzed to be the best way to fill this in. So it goes from 32 to 35, and it looks like it goes up a little bit, then down, and then back up again. And we can also try and do this with a higher order function. So interpolate method equals polynomial. Let's see what that looks like. 232, then it goes 232.2 roughly, 232.4, and then up 234.2 roughly, and then 235. So quite a smooth curve again, and you can keep going up. I'm not sure if this data set works for order 4, but I suppose we could try it. Oh, and it does. Okay. So this fits a 4th order polynomial function to our data set, and it estimates the missing data based on that. So let's see this once again. And so this goes up, back down, up again, and then back down again. So this really depends on your data. You will need to sort of figure out which order polynomial will best fit your data. But that's how you use that. Finally, moving on to time, and this one, we will have to make sure that the time in column is the index, and also make sure that it's formatted correctly, as we did in the beginning of the episode. And for this one, we can only use the machine data set, because that's the one that we formatted to be able to do this with. And what this does, essentially, is that, remember at the beginning of the episode when we mentioned that for the linear method, it did not take the index into account when calculating the data? Well, with the time method, it actually does take that into account. So it looks at the data set, it looks at the difference in time between all of the pieces of data, and then it finds where that data would be on that timeline, basically. So it's a lot more accurate when you're using time interval based data. So let's really quickly take a look at machine once more, and we'll now use the time interpolation method. So machine.interpolate method equals time, and there we go. So we can check out any of these areas. Let's say this area here. So we have a jump from 3 o'clock to 6 o'clock to 8 o'clock, or almost 9, 8:56. And you can see here the data is not filled in linearly, but there are differently sized jumps from one bit of data to the next bit of data. So over here, for example, we only moved up by 0.14 because the jump from we've got a jump from 2:45 to 3, which is only 20 minutes. 3:05, sorry. But then we've got a bigger jump here, so from 3:05 to 6:21, and as you can see, the jump in the values between these two values is actually quite large compared to the jump between these two values. So it just takes that into account. So let's say we want to fill in data in our data set, but where there are big gaps, we don't want to estimate all of that because that can lead to inaccuracies. So what we can do here is we can take a look at our revision data set, and for this we're going to use limit, and limit allows us to basically set, okay, let's say we have a gap of 3. I don't want to fill in all of those, just fill in 1. Okay, so what we would do is we would use revision.interpolate, so we're going to interpolate it, and we're going to set the limit to 1. Now, before we run this, let's take a look at our data set real quick. We have a number of missing values here. So we've got a gap here with 2 missing values, another gap here, and another one here. And so it's going to take a look at all of these gaps, and it's going to only fill in 1. So for example, in this column here, we have a missing piece of data here, and another missing piece of data here, but it's only going to fill in 1 of them. And another piece of data here, but since this one is alone, it will fill that in. So let's run this and see what happens. So as you can see, where we have large gaps, where we have initial data, missing data, it will not fill that data in. However, where we do have data with which it is surrounded by enough non-missing data that we can interpolate it from, or that we can use that data to estimate, it has done so. We can even set the limit to 2 and see what that looks like. And as you can see, that's what it's done. So let's really quickly try and take a look at what this does to a machine. And as you can see here, we have 3 pieces of missing data. So what we can do is we can do machine.interpolate, and we can set the limit to 2. And as you can see, there is still a missing value here. We can also set this to 3, and now all of those values have been filled in. We can also set a limit direction. And I think the best way to demonstrate this is simply by printing out our data, so like so, and then using this method. So vision.interpolate limit direction equals, and now we can choose from any of these. Let's start with forward and see what it does to our data. So we have this missing data here. Now, whenever we go forward from the top, we can take a look at the previous data and we can use that to fill in the next data. And if we were to do this with backwards, this is what we would get. So notice that this missing value here has been filled in now, and this one has not. What we're doing basically is the opposite of what we were doing before. Instead of going from the top of the data down and then basing it on the data above, we're actually going from the bottom and basing it on the data below. So in this case, over here, there is no data below this missing value to interpolate with, so we can't estimate that value. But actually, where we had a missing value here after interpolation, we no longer have that because we have a value below for it to estimate that value with. What we can also do is consider both directions. So we can interpolate here. And we set this to both. As you can see, all missing values have been filled in because we're not only taking a look at the values below or the values above, but we're taking a look at both. So even the values on the top and the bottom have been filled in. When we're trying to estimate data inside of a data set, or when we're trying to estimate data based on the data inside of a data set, that's called interpolation. That's what we've been doing. When we try to fill in data outside of the data set based on information from the data set itself, that's something called extrapolation. And we can actually do that with this function as well. We're going to have to use something called limit area. So what we can do here is we can take a look at our machine data set. And as you can see, we have some data on the outside, which doesn't have any data above it or below it. So for example, this piece of data here doesn't have anything below it, but it's on the edge. And we have some data on the inside. So all of these missing values here are surrounded by other values that are not missing. And this one as well, this one here, this one, this one. There are plenty. These ones here, for example. So if we want to specify that we don't want to extrapolate data, we only want to interpolate data, what we can do is we can set the limit area to inside. Let's try interpolating using that principle. There we go. Now let's see the effect of that. In machine, we had two outer missing elements. This was this one here and this one here. Once we set it to inside, so only interpolation, all of the missing values on the inside have been filled in. But what if we want to fill in the missing values on the outside? And there is a little quirk to this as well. So you'd think that we can just do interpolate with the limit area equals outside. And this does work. This does fill in missing data on the outside. So it does extrapolate. However, there is a little quirk to notice. So first of all, let's point out that all of these inner missing pieces of data have not been filled in. But the outer pieces of data have also not been filled in. This one has, but this one has not. So this is just a quirk of Pandas. What you will need to do is use something that we've used before. What we can do is set the limit direction to both. There we go. And now, if we try this, both of these pieces of missing data will be filled in. There we go. We can also try this with revision. So let's first see what it looks like. And then let's interpolate it. First on the inside. So interpolation. And then we'll copy this code to make it quicker. And look at what it looks like on the outside. And let's not forget to put the limit direction to both. There we go. As you can see, we have two pieces of missing data on the outside here that have not been filled in. And here, they have been filled in, whereas the inner data, which was filled in here, was not filled in. Finally, let's look at in place. So, essentially, everything we've been doing in this episode doesn't actually change the original variable. You can see I've been using the same variable throughout all of these. So revision.interpolate, and it uses the original data set that we had, right? So if we want to change what the data set looks like, we can do something like this, and we'll use in place. That's what in place does, is whatever changes we make will be saved to the variable instead of creating a new variable. So let's take a look at revision. This is what it looks like, right? This is what the variable looks like, the one that we've been using this entire episode. Next, let's interpolate it. So exactly what we've been doing this whole time. And this is what the interpolated revision variable looks like, or the data frame, the data set. But if we take a look at revision again, the original variable itself, it actually hasn't changed. It doesn't look like this. This is what it looks like, right? So if we want to change what revision looks like, what we're going to have to do is interpolate it, and then we're going to use this over here in place. We're going to set it to true. Okay. And then we're going to take a look at revision. So maybe let me create a new code block. And now the variable has changed, whereas before, when we tried to take a look at the variable by itself before interpolation, it did not change. It was the same as it was before, as you can see. So after we interpolated it with in place, it actually changed the variable itself instead of giving us a new variable to look at. Thank you for watching. If you enjoyed this episode, then please like, subscribe, and hit that bell icon if you want to see more of our episodes. They'll be sent to your feed. And if you want the source code for this episode, it's available in the description or at this link. It's also available on our website if you try and access the Pandas section. If you want to check out our other playlists, we have a Python playlist and a NumPy playlist. And we are also working on some other playlists if you want to check those out as well. If you thought this episode was cool and it was easy to follow and you learned something, then maybe share it with a friend so that they can also learn from this episode. Thank you so much for watching. Have a lovely day, and we'll see you in the next episode. Bye-bye.